Welcome back to my channel, dear students. So today we will continue our integration using substitution. So today we will see few very important special forms of integration. Okay, so we are calling it elementary rules of integration. So under this we have four different categories, that is type A, type B, type C and type D. Okay, so we will see these rules or these forms very carefully while doing the sums. Okay, now you may pause the video to note down the forms in your notebook. Okay, so let's begin with the type A kinds of integrals. Now if you see this integral, let me call this to be I, okay, and I have to prove that this I will be equals to this much, okay, and this falls under this category. Yes, and the rule says that we have to take ax plus b equals to z, okay, and here ax plus b is this one. Let, as the rule says, ax plus b must be equals to z, that is 5 minus 7x equals to z. So basically, since you are doing integration using substitution, here you are substituting the variable x with z, so that's why I need to remove this dx as well. Now what I need to do, I need to differentiate both sides. So differentiation of 5 will be 0 and differentiation of minus 7x will be just minus 7. So I have dx equals to dz. So we want the value of dx. So from here dx will be equals to minus 1 by 7 dz, right? So this minus 7 goes here and becomes minus 1 by 7. So my I becomes integral. Now dx is how much? This much, right? So this minus 1 by 7 can be kept outside integral. So we have dz by, how much is this? This is equals to z, and this is nothing but log of z, right? And what is z? So z is, the value of z is 5 minus 7x. Now you must be wondering, why am I putting this modulus? This is to ensure that this part is positive, because we cannot have negative within log, okay? And here we have to put one constant of integration. Okay, so how many ever questions you are going to see, I have not written plus c over there, okay? So you have to assume that there will be plus c, that is constant of integration. Is that clear? So this is our first problem. Now let us go to the second problem of the very same kind, that is type A, and the next problem is this one. So we have to verify this, okay? So 8 minus square root of 8 minus 7x dx will be equals to minus 2 by 21 8 minus 7x to the power 3 by 2. So let's verify this integral. Now as usual, let me take this to be I, okay, and since this is also falling under this category, square root of ax plus b dx, again the rule says take ax plus b equals to z, okay? So let 8 minus 7x equals to z, okay? So as usual we'll differentiate, so we will differentiate to get 0 minus 7 dx equals to dz. So again I am getting how much? From here I am getting dx equals to minus 1 by 7 dz. So therefore your I becomes, now dx is how much? This much, right? So this minus 1 by 7 will be kept outside integral sign. So instead of dx I am writing dz now, okay? And square root of, how much is this full thing? This is equals to z, right? So this is minus 1 by 7 integral of z to the power half dz, right? And how much is this? This is minus 1 by 7. This is x to the power n. So integral of x to the power n will be x to the power n plus 1 whole divided by n plus 1, yes, with constant of integration, right? So similarly you will put constant of integration here. So minus 1 by 7. Let's simplify this further. So this is z to the power 3 by 2 whole divided by this also 3 by 2 plus c. So this 2 goes to the numerator and 7 into 3 is 21. So this is minus 2 by 21 z to the power 3 by 2. And what is z? Z is equals to 8 minus 7x to the power 3 by 2 with constant of integration. So that's what we needed to verify. So you may pause the video to note down. Okay, now let's have a look at this particular problem. Now again, this is falling under type A. Okay, so type A says, if I call this to be I, type A says that we have to take this to be Z. Okay, so let 3 minus 4x equals to Z. As usual, differentiate. So you'll get minus 4 dx equals to dz, right? So from here, dx will be equals to minus 1 by 4 dz. So therefore my integral I will change to, okay, so instead of this dx I am writing this much. So this is minus 1 by 4 is kept outside. So we have dz by this full thing is z. So it is z to the power 2 by 3. So we have minus 1 by 4 integral of z to the power minus 2 by 3 dz, right? So x to the power n form is there. So my formula says it will be x to the power n plus 1 divided by n plus 1. Okay, so since we are done with the integral part, we'll put constant of integration. Now let's simplify. So minus 1 by 4 into this is z to the power how much? 1 by 3. Similarly we have 1 by 3 here. So this 3 goes here. So we have minus 3 by 4 z to the power 1 by 3. So what is z? Z is 3 minus 4x. So 3 minus 4x to the power 1 by 3 with constant of integration. So we have verified our integral. Now we need to verify the next problem, that is this integral will be equals to this much. Let me call this to be I. So again, this is falling under your type B. If you see, if you compare, this falls under type B, and type B says we have to put, okay, so in type B this particular integral falls under this category, ax plus b whole divided by cx plus d dx, right? And the rule says that cx plus d must be taken to be z, that is this has to be substituted as z. So let's see what happens if I substitute this to be z. So we have let 4x plus 5 equals to z. So as we are substituting x with z, let's remove this dx as well. So from here I am getting 4 dx plus 0. I am not writing that, it will be equals to dz, and from here what is dx? Dx is equals to 1 by 4 dz. Now let's see what is happening to I. So therefore this I becomes, so this 1 by 4 I'll keep outside. Okay, so from here let's see what is the value of x. So from here x will be equals to, this 5 goes there first, so z minus 5 whole divided by this 4 goes down, right? So we have 3x, and how much is x? X is z minus 5 by 4 plus 4 is there whole divided by this full thing is equals to z. Okay, and instead of dx I have written 1 by 4 outside, and I have to write dz also. Okay, simplify this, we have 1 by 4. Okay, so we have, after simplifying, so 4 into 4 is 16, right? Plus is there, so 3z minus 3 into 15, right? Divide by 4 and z are together, so that is 4z dz. Is that clear? Okay, so we have 1 by 4 3z by 4z. I am separating the integral dz. Okay, and 16 minus 15 is 1, so we have 1 by 4, this 1 by 4. Okay, and we have 1 by 4z dz. Okay, so z and z gets cancelled, so this 3 by 4 comes outside, so becomes 3 by 16 integral dz, plus similarly here we have 1 by 16 integral dz by z, right? So integral dz means z, right, plus 1 by 16. Now from here it will be log z, right? So you can put modulus with constant of integration. So let me take 1 by 16 common, because we need to take 1 by 16 common. So here we have got 3z left, right? So z is equals to this much, so that's why 3z will be equals to 3 into 4, that is 12x, plus 3 into 5, that is 15, plus log z. And what is z? Z is equals to 4x plus 5, right, with constant of integration. So you may pause the video to note down. Now let us verify this particular integral, and again this falls under type B. Okay, so in type B we have a form which says x to the power m divided by cx plus d to the power n dx, where this m is a positive integer. Okay, m is a positive integer. This is very important. Now if I compare this with this, here the power of m is x is 1, right, and we know that 1 is a positive integer. So according to the rule, what we need to do is we need to substitute this cx plus d to be z. Okay, so here instead of cx plus d we have ax plus b. So let me do that. So let ax plus b equals to z, right? Okay, so from here we have a dx equals to dz, right? So that is dx is equals to 1 by a dz. Fine. So if I call this my I, then I will be equals to, okay, so from here let's see what is the value of x as well. So from here we see that x is equal to z minus b whole divided by this a goes down, right? So x is equals to z minus b whole divided by a. So instead of this x I am writing z minus b by a, okay, whole divided by ax plus b to the power 2 by 3. So x plus b is z to the power 2 by 3, and we have dx, and instead of dx we have to write 1 by a dz. So let me write this 1 by a outside. So 1 by a comes outside, so we have only dz out here. Okay, let's simplify this. So if I simplify this, I'll get 1 by a, so this is z to the power 2 by 3 by 1. Yes, so if I invert it, what will happen? This, okay, so if I invert this, I'll get z minus b whole divided by a. This divided by becomes into, and this becomes the reciprocal, that is 1 by z to the power 2 by 3 dz. Okay, so this 1 by a can be again kept outside. So if I do that, then I have 1 by a square. So this is z to the power, okay, z minus b to the whole divided by z to the power 2 by 3 dz. Fine. Now let us distribute this division over this minus sign, that is a square. Okay, so let me do z by z to the power 2 by 3 dz minus this b is there, so b can be kept outside integral sign, so we have dz by z to the power 2 by 3, right? So this can be written as 1 by a square. Okay, so how much is this? Z, it is z to the power 1, so this can be written as z to the power 1 minus 2 by 3 dz, right? Minus b, this is z to the power minus 2 by 3 dz. Okay, so this is how much? This is equals to 1 by 3. So this is in the form x to the power n. So this will be x to the power n plus 1 whole divided by n plus 1. Okay, now similarly we have minus b. This is also in the form of x to the power n, so we have x to the power n plus 1 divided by n plus 1. Okay, with constant of integration. Now I don't have space, so let me write here. Okay, now if I simplify this, okay, so we have 1 by a square, right, and this is z to the power 4 by 3, right, and how much this becomes? This is 4 by 3, and after inverting itself it becomes 3 by 4. Is that clear? Okay, similarly this, after simplification, the power becomes 1 by 3, and similarly denominator also becomes 1 by 3, but after inverting itself this 1 by 3 becomes 3 by 1, which is nothing but 3, so that's why it becomes 3b. Okay, so along with this b it becomes 3b, and it becomes z to the power 1 by 3. Now let us resubstitute the value of z in this particular thing. So here we see that 3 is also common, right? So let me take out this 3 outside. So we have 3 by a square, and here 1 by 4 left, and what is z? Z is equals to ax plus b. Okay, so ax plus b whole to the power 4 by 3 minus b, and again substituting the value of z, that is ax plus b whole to the power 1 by 3 with constant of integration. So pause the video to note down. Now this particular question falls again under type B. Okay, but this time this is a definite integral, so that's why we are not going to have any constant of integration after we solve it. Okay, let's begin. So let me call this to be I. Okay, so since this falls under type B, so we have to take denominator. This is my ax plus b whole divided by cx plus d, so we have to take cx plus d equals to z. Okay, so let 1 plus x equals to z. So from here what is x? From here x is equals to z minus 1. Okay, now so we have to differentiate this. So after differentiating I'll get dx equals to dz. Fine. Now again what we need to do is we need to change the variables as well. Okay, we need to change the limits as well. Now when x is equals to 0, then what is the value of z? Then the value of z will be 1 plus 0, that is 1. Okay, now similarly when x is equals to 1, then z will be equals to 1 plus 1, that is 2. Okay, so therefore your I will change into, okay, so dx is equals to dz, so we have integral 1 to 2, right? So 1 to 2, 1 minus x, and how much is x? X is z minus 1. Okay, divided by 1 plus x, this is equals to z, and what is dx? Dx is equals to dz. Let's simplify this. So we have 1 to 2, let's open the bracket, so we have minus into minus plus 1, so plus 1 and plus 1 gives me 2 minus z by z. Okay, so again after I split this I'll get 1 to 2, 2 by z dz minus 1 to 2 z by z dz, right? So z and z gets cancelled, so this is 1 to 2 dz by z minus integral 1 to 2 dz, right? So this will be equals to, from here, so this is equal to 2. Now integral of dz by z is log z, upper limit is 2 and lower limit is 1, minus integral of dz will be z, upper limit is 2, lower limit is 1. So let us substitute the values of upper limit and lower limit. So we have 2 log 2 minus log 1, right, minus 2 minus 1, right? So we know that log 1 is how much? Log 1 is 0, so we have 2 log 2 minus, how much is this? It's 1. So that's what we need to show. So pause the video to note down. Okay, so let's have a look at next question. So next question is going to be a bit complicated because we are going to have a long answer like this. Okay, and this falls under your type C. So according to type C, it is said that the sum of the powers, that is m plus n, has to be a positive integer greater than 1, right? So 3 plus 2 is 5, and it is obviously a positive integer and it is greater than 1. Okay, now according to the rule, whatever is this inside this, that has to be substituted with xz. Okay, so that's why I'm taking, if I call this as I have to take, let a plus bx equals to zx or xz, whatever you want to call it. Okay, and next what you are going to do is you will divide both side by x. Okay, so if you do that, then you will get, okay, so if you divide both side by x, then you will get a by x plus b equals to z, right? Now let us differentiate this. So if you differentiate a by x, this a will come outside, right? A will come outside, and we have differentiation of 1 by x, that is x to the power minus 1. So this will be differentiation of x to the power minus 1 will be minus 1 x to the power minus 1 minus 1, that is minus 1 by x square. Okay, so this is minus 1 by x square dx. Differentiation of b will be 0, so no need to write that. So we have dz from here. Is that clear? Okay, but we need what? We need dx by, okay, let me calculate what is dx from here. So we have dx is equals to minus, this minus also goes here, so x square dz by a. Is that clear? Now let us see what is the value from value of x from here as well. So let me take this bx here and let me take x common. So if I take x common, then I have z minus b equals to how much? A. So from here what is x? So x will be equals to a by z minus b. Okay, so let us substitute all this thing in I. So my I becomes, okay, so we have dx equals to this much, right? So integral of, so dx can be written as minus x square dz by a divided by x cube. Let me write it x cube itself right now. Ax plus b, sorry, a plus bx is how much? It is zx. So zx square is z square x square. Okay, so x square and x square gets cancelled, right? So minus 1 by a can be kept outside. So minus 1 by a is kept outside. Okay, so we have dz by z square is already there, right? Okay, x cube. Now what is x? X is in this much. So that's why I will write x cube as a by z minus b whole cube. Okay, so let us simplify this. So from here this is a cube. So let me take this a cube outside. So it becomes again minus 1 by a to the power 4. So z minus b whole cube, it goes to the numerator. So z minus b whole cube by z square dz, right? So this is all we get. So let us simplify this further. So we have equals to minus 1 by a to the power 4. Let me apply a minus b whole cube formula. So a minus b whole cube formula says a cube minus 3a square b plus 3a b square minus b cube, right? So this is your formula for a minus b whole cube divided by z square dz. Okay, so minus 1 by a to the power 4. So let us again divide all this term one by one. So we have integral z cube by z square is z dz, right? So similarly we have minus 3b outside, right? So z square by z square is this is 1, so that is it will be only dz, right? So plus 3b square will be kept outside, so 3b square is outside. So we have z by z square, which is 1 by z, so this is dz by z, and at last it is minus b cube, it will be kept outside, and we have how much is there? So we have 1 by z square, which can be written as z to the power minus 2 dz. Is that clear? Okay, now let us apply the integral formula. So a to the power 4, integral of dz is z square by 2, that is half of z square, right? Minus 3b, integral of dz is z, right? So you just omit this part, don't get confused. So integral of dz will be z plus 3b square. Now this becomes your log of z. Yes, okay, and we have minus b cube z to the power minus 2. It will be z to the power minus 2 plus 1 divided by minus 2 plus 1 with constant of integration, right? Okay, now in our answer we have 2 as well, so let me take 2 common here. Okay, so we have minus 1 by 2 a to the power 4. So here we have z square, and what is z? Z is equals to this much, right? Okay, so or else what you can say is if you divide both sides by x, what will you get? You will get z equals to a plus bx by x, right? Why am I using this? Because in our answer we have only this one. Okay, so instead of z I am writing this much. So here we have a plus bx by x whole square minus, okay, now next is, okay, let me keep this 1 by 2 here itself, because this is not common. Here we have got a to the power 4 in each and every term, so let me keep this 1 by a to the power 4 outside. So here we have half. Okay, now we have minus 3b z, and how much is z? Z is again a plus bx by x plus 3b square, right? That is 3b square log of z, and again we know that z is a plus bx by x. Okay, and at last we have got minus b cube, and how much is this? This is minus 1, so minus 1 into minus becomes plus, right? So plus b cube into z to the power minus 1, that is z is a plus bx by x to the power minus 1, okay, with constant of integration. Now let us open the bracket by multiplying with minus 1 by a square. So if I do that, then I'll get minus, okay, so since it is minus outside, so all these signs will change. Okay, so we have minus 1 by 2 a to the power 4 a plus bx by x square. This is the first one. This becomes minus into minus plus, so we have plus 3b by a to the power 4 a plus bx by x. So this is my second term. This plus becomes minus, so we have 3b square by a to the power 4 log of a plus bx by x, right? And the last one, that is this plus becomes minus, we have b cube by a to the power 4, so we have this to the power minus 1, so that basically it inverts itself, so it becomes x by a plus bx, right, with constant of integration at last. So this is what we need to prove. So pause the video to note down. Now let's have a look at the fourth kind of problem, that is type 4, where the rule says we have to rationalize the denominator. And before you rationalize, you have to make sure that the coefficient of x are equal. So basically in that form it was written ax plus b, and here also it was written ax plus c or d. Okay, now from there we came to know that the coefficient of x were equal. Similarly here we see that there is 3, here also we have got 3. So during this case what we need to do is we need to rationalize the denominator. Okay, so we have, if I call this to be I, so therefore my I becomes dx by whatever is written, I am writing that. So 3x plus 4 plus square root of 3x minus 10. And how do you rationalize? You will multiply with its conjugate, that is 3x plus 4, you'll write minus here, so 3x minus 10. So again you have to write down the same thing here, so 3x plus 4 minus 3x minus 10. Okay, so let us rationalize this. So here we have got just 1, so after multiplying you will get this much itself. So we have 3x plus 4 minus 3x minus 10. In the denominator you will get a plus b into a minus b, that is a square minus b square. And what is a? A is square root of 3x plus 4 and b is square root of 3x minus 10. Okay, as usual you can remove this and this. Similarly this and this can be removed. Okay, so we have dx here. So let us simplify this. So we have integral of square root of 3x plus 4 minus square root of 3x minus 10 divided by, okay, so here we have 3x plus 4 left. So 3x plus 4. Now since there is minus, here we have got 3x minus 10. Now because of this minus, all this sign will change after multiplication. That is, it becomes minus 3x plus 10. So we have dx outside, right? So this and this gets cancelled. So 4 plus 10 is how much? It is 14. Okay, so this 14 will be kept outside. So if I keep this 14 outside, then I have two integrals. One is square root integral of square root of 3x plus 4 dx minus another will be 3x minus 10 dx. Right? Now this falls under your type A. Both of them falls under type A. So let me call this to be 1. Okay, and let me call this integral to be I1, and let me call this integral to be I2. So first let us simplify, or let us evaluate I1. Okay, now to evaluate I1, what I need to do is, let me take this to be U. Okay, so we have, let 3x plus 4 equals to U. Okay, so from here we see that dx will be equals to 1 by 3 du. Okay, so therefore this means that I1 will be equals to, this one will be equals to integral of, this full thing is equals to how much? U, right? And what is dx? Dx is equals to 1 by 3 du. That is, how much is this? This is u to the power half. So this will become 1 by 3 u to the power half plus 1 half plus 1. So how much is this? This is 3 by 2. So this becomes 2 by 3 into 3 becomes 9. So u, that is 3x plus 4 to the power 3 by 2. So we got our I1. Is that clear? Similarly, let us find what is our I2. So to calculate I2, let me take 3x minus 10 to be equals to v. So from here, dx will be equals to 1 by 3 dv, right? So from here, we see that I2 will be equals to integral of square root of, this full thing is equals to how much? It is v, right? And dx is equals to how much? 1 by 3 dv. Right, so let us apply the same formula here. So we have 1 by 3 v to the power half plus 1 divided by half plus 1, that is 2 by 9 again, right? So v is how much? V is equals to 3x minus 10 to the power 3 by 2. Okay, so therefore my I will change into, therefore my I will be equals to 1 by 14. Now we have got I1, and how much is I1? I1 will be equals to 2 by 9 into 3x plus 4 to the power 3 by 2 minus, and how much is I2? I2 is 2 by 9 into 3x minus 10 to the power 3 by 2, right? So again you can take out 2 by 9 common, just write constant of integration, so 2 by 9 comes outside, right? So we have 1 by 14 into 2 by 9, so we have 3x plus 4 to the power 3 by 2 minus 3x minus 10 to the power 3 by 2 with constant of integration. Again this and this gets cancelled, so 7 into 9 is 63. So that's what we get, and the rest are same, right? So you may pause the video to note down. Now let us check the last sum of the day, and again here we are dealing with definite integrals. So that means our answer will be independent of constant of integration. Okay, now let me call this to be I. Fine. So again this is falling under which category? It is falling under type D. Okay, so type D says rationalize the denominator. So before rationalizing, let's check out whether the coefficient of x are equal or not. So here the coefficient of x is 1, similarly the coefficient of x is 1. So that means we will be able to rationalize the denominator here. So we have I equals to 0 to 2 dx by, okay, so we have x plus 3 minus square root of x plus 1. So if you want to rationalize this, you have to multiply it by this much, right? So after multiplying, let's see what do we get. So we see that it will be equals to, so let me write dx here. So we have 0 to 2. Okay, so we have x plus 3 plus square root of x plus 1. This is a square minus b square. So a minus b into a plus b gives me a square minus b square. And what is a? A is square root of x plus 3. What is b? B is square root of x plus 1. So as usual, this and this can be removed. This and this can be removed. So we have dx here. So we have 0 to 2. Okay, so this is square root of x plus 3 plus square root of x plus 1. Now this is x plus 3, and because of this minus, all the sign will get changed. So we have this much. So here this and this gets cancelled. So 3 minus 1 is 2. So let me write that 2 outside. So we have integral of 0 to 2 square root of x plus 3 dx plus integral 0 to 2 square root of x plus 1 dx. Okay, so as usual, let me call this to be I1 and let me call this to be I2. Okay, so to evaluate I1, so this is again falling under which category? It is falling under type A, right? So type A says we have to take this to be some u, right? So let me write to evaluate I1. So let x plus 3 equals to u. So from here I see that dx will be equals to du, right? And one more thing, that is the limit. Okay, so when or x equals to 0 implies u equals to how much? 0 plus 3, that is 3. Okay, and we have x equals to 2 implies u equals to how much? 2 plus 3, that is 5. Okay, so I don't have space, so let me write it here. So therefore your I1 will become, 0 to 2 becomes 3 to 5, 3 to 5 square root of, how much is x plus 3? X plus 3 is u. So u du, right? So this will be equals to u to the power half plus 1 with lower limit and upper limit. Fine. So this is again 3 by 2. So after inverting itself, it becomes 2 by 3. So we have 2 by 3. This is u to the power, how much? U to the power 3 by 2. So lower limit, upper limit. Okay. So we have from here, so 2 by 3, 5 to the power 3 by 2 minus 3 to the power 3 by 2. Okay, so this is my I1. Now let us evaluate what is our I2. So to evaluate I2, that is this one. So let me take square root of, or x plus 1 equals to v. Okay, so therefore this means dx will be equals to dv, and again when x goes to 0 or when x is 0, this means v will be equals to 0 plus 1, that is 1. Yes, and when x is equals to 2, then v will be equals to how much? It will be 3. Okay, so therefore your I2 will become integral 0 to 2, that is 1 to 3 square root of v dv, and again this is equals to how much? This is 2 by 3 v to the power 3 by 2 lower limit, upper limit. Okay, let us put the value of lower limit and upper limit. So we have 3 to the power 3 by 2 minus 1 to the power 3 by. Okay, so we know that 1 to the power 3 by 2 or 1 to the power anything becomes 1 itself, right? Okay, so that's why this can be written as 2 by 3, 3 to the power 3 by 2 minus 1. Okay, now let us combine this I1 and I2 in this one. Okay, so therefore I will become, I is equals to half I1. So half I1 is this much plus I2, and I2 is this much. So we see that 2 by 3 is also common. So let me take out 2 by 3 outside. Okay, so we have 1 by 2 into 2 by 3. So this 2 and 2 gets cancelled. So we have 1 by 3 left. So from here we have 5 to the power 3 by 2 minus 3 to the power 3 by 2. And from here plus 3 to the power 3 by 2 minus 1. So these two again gets cancelled. And what is 5 to the power 3 by 2? 5 to the power 3 by 2 is nothing but 5 root 5, and we have got minus 1 here. So that's what we need to prove according to the question. Now you may pause the video to note down, and one more thing I would like to say is the questions for practice will be given in the description. So go to the description and download the PDF in order to practice the sums at home. Thank you very much.